All right, so f of x equals negative 2x squared. Right away, we can tell there, this is a parabola. I've added an extra term there, but that's not going to change the fact that it's a parabola, is it? Because it's x squared. The 1 doesn't change anything about that. And what about opens up or down?
No.
Be opening down. Because again, the number in the front of the x squared is negative, so it opens down. And is this wider or narrower than f of x equals x squared? Wider or narrower?
Wider.
No.
Be narrower, wouldn't it? Because again, just looking at the positive part of the x squared number in front, it's 2. And if that number is bigger than 1, it's wider, narrower. It is narrower. It makes it more narrow. All right. Well, let's see see what happens to our graph here. -1, -2, -1, 0, 1, and 2. Again, just plugging in these numbers to the function there. So this one would be -2 times, again, +4. Then you're multiplying by -2, so that would be -8 plus 1, so that's a -7. So the y value you get there is -7. So you just have to work your way through. Let's do this to the side here. All right, so at -1 we'd have -2 times -1 squared plus 1. Well, that's -2 times +1 plus 1, so that's -2 plus 1, that's -1. So -1, we got negative. And 0, of course, 0 part is 0. So you have -2. -2 times 0 plus 1. Well, that's still 0. And then you add the 1. So actually at 0 we get 1. Add 1. Of course, that's do the 1 squared. You got 1 plus. So you have -2 times 1, that's -2, and then you add 1, so you're back to -1. 1. And then last but not least, at -2, so we got -2 times 2 squared plus 1. Square the first, square it first, so we got -2 times 4 plus 1, then you do the multiply, so that's -8 plus 1, so that's -7. Again, it's kind of nice little table there. All right, here's the thing I was going to mention on this. The graph then looks like this. -2 and -7. Here, -1, -1. 0, 1, so it's up on the y-axis there at 1. 1 and -1. And 2 and -7. Yeah, so we get this opening down. Parabola. But what I'd like for you to note there is that this one is shifted. We have shifted this one. Not only have we flipped it over, but we shifted it. Meaning, one thing we've shifted here is the what's the vertex here? What's the HK? Well, here's the vertex right here, isn't it? 0, 1. So I flipped it over and I've shifted it. Okay, well, that's what happens when you play around, you add things to this quadratic function, is it shifts it around. And this one, it happened, just shifted it up, but you can shift it up, down, right, left, and we could do a lot more with this, but just note that. All right. So sometimes the vertex is different. It gets, things happen, so you get shifts and things like that. Okay. So let's talk about just the standard form, because here's what we're going to go to next on this. So this is standard form of a quadratic function. F of x equals ax squared plus bx plus c. We'll call that standard form. Give it a name. Well, yeah, so we've added a little more to it. A, B, and C are just numbers. They are just numbers. But that A is pretty significant, isn't it? Because what does A tell me? Whether it opens up or down. If it's negative, it opens down, right? If A is positive, it opens up. It also tells me about wider or narrower. And then the B and the C, well, we'll come up with a use for some of that anyway in a minute. But yeah, the A, B, and C are just the numbers here. And now, if, let's just say, if A is positive, what have we got there? Opens up, it opens up. Parabola, it opens up. And I'm not, we can't exactly graph this, but hopefully from what we talked about a little bit earlier, just a few minutes ago, any numbers we could plug in there, A being positive and the B and the C, any numbers there we could plug in, that's going to shift this thing around. And so, depending on how it's shifted, our parabola is going to be shifted. And like I said, it could be up and down, right, left, any kind of combination there. So let's say this one, in general, we'll just say, it looks like this. We know it's a parabola that opens up, so let's just put one up here. Yeah, and so what I want to talk about here, in a minute or two here, is the vertex. Well, if this parabola gets shifted around, that shifts around the vertex. And that's kind of what I want to focus on with you the remaining time here, is this vertex, H comma K. And if, I guess we just throw the other up here, if A is negative, parabola opens down. Like I said, it could be shifted any which way, but let's just say, all right, we've got this. For this function here, A is negative, so I know it. So here's my vertex here. H comma K. So comparing these two, just kind of in general, when we've got a parabola that opens up, is the vertex a high point or a low point? It's a low point, right? If our parabola opens up, the vertex is a low point. If the parabola opens down, the vertex is a high point. So keep that in mind. I've mentioned that a couple of times now, but that is significant. We'll mention something more about that in a second. All right, okay. So that's what, in general, a standard form of a quadratic function looks like. Ax squared plus bx plus c. So let's talk about one specific one here. F of x equals minus x squared plus 4x plus 5. Now I'm not assigning any to graph here, but let me just show you what some points here on this one would be. Well, 0 would be an easy one. It's 0, 5. 1, yeah, 1 we're at, what did I do 1? 1 would be at 8. 2 I'm at 9. 2 I'm at 9. 2, 9 is a point. A couple others. -1 and 0. And like I said, you won't have to figure these out. I'm just showing you what they are for a point here. 3 we're also at that's 7. 3, 7. And I have 4, 5. And then last one I'll do is 5, 0. Figure those out if you want to, but I'm just telling you what they are. Okay. So here's our problem. What we expected, right? Opening down, shifted different ways, but the opening down is easy, right? That makes sense. Makes sense. That's what it looks like. All right. Well, here's what I want to show you. What's the vertex here? What's the HK? 2, 9, right? So the H is 2, the K is 9. Well, yeah, we kind of found it by me giving you those points, but what we'll have to do is find those without maybe having those points or this graph displayed. So here's an interesting little thing. Call it the Vertex Formula. H equals, let's compute this. H equals -b over 2a. Now again, what am I referring to there? B and A. Well, A, B, C, f of x equals ax squared plus bx plus c. So I'm referring to the a and the b from that. So in this particular case, all right, so the a comes in front of the x squared. Well, it's a negative, so we'd have to say that's -1. And then the b is what's in front of the x, so the b here is 4. That's what I'm referring to in this formula. -b over 2a. That is, in this particular case, so it'd be -b, so it's the opposite of this b, so it's -4, over 2 times a, so 2 times -1. What does that give you? -4 over -2, which is +2, isn't it? +2. And that's not coincidence that that matches with what we found, the h to be over here. The h was 2, wasn't it? Yeah, so this little formula right here is going to give you the h of the vertex. Now the k, where does the k come in? Well, k, we can just say k is f of h. Use our function notation. K is f of h. What does that mean? Well, in this case, it means f of 2. Which means plug in, what does this mean? f of 2. That means plug in two corrects, yeah. Plug in the 2 corrects. So I have negative, and then, yeah, this negative is not part of the squared, so it's just the 2 squared, then the negative. Plus 4 times 2 plus 5, so that's negative 4, plus 8 plus 5, which is 9. So yeah, this 2 squared is 4, but we got the negative, so that's why it's negative 4. The square does not contain that negative. So that's why that's negative 4. Hey, look at that. Isn't that exactly what we found right there? Yeah. So without graphing this, we can actually figure out the vertex of the parabola using these 2 little equations. For f of x equals ax squared plus bx plus c. The vertex is given by h equals negative b over 2a, and then k equals that f of h. Call it the vertex. So we call that the vertex form. For easy reference. Okay, so now, one other point before I erase this one, move on to the next. Is that vertex high point or low point? It's a high point, right? It is a high point. So our vertex here is the high point. Negative 2, positive 2, 9 is the high point. Well, the other, in just a second, the other step we're going to take for this is to note that if it's a high point, that's going to be a maximum. It's a maximum, okay? Call it the maximum. We'll talk about what's maximum in a second. It's the maximum. Okay. All right. Let me do one of these and then we'll show you an application. That. Okay. So we're not going to graph this one. We're just going to do this. All right. So f of x equals, just make one up. Let's make it 2x squared minus 7x minus whatever. Okay. What's the vertex? Well, we haven't graphed it, so read it right off the graphs. The last one. No, in this case, we can use our vertex formula. H equals negative b over 2a, which in this case we've got a is 2, b is negative 7. And so the negative b means the opposite of b, or if you want to write it out, what I've got here is negative of negative 7. So negative b is actually going to be positive 7, right, because the double negative. 2 times a, so it'll be 2 times 2. It's going to be positive 7 over 4. Right? Well, let's go ahead and change that to a decimal. That would be 1.75. And since it's just 2 decimal places, we could round. We just need kind of an approximation, but let's just leave it 1.75. So that's the h of the vertex. What's the k? Well, k is f of h. All right, plugging the h into the function. So in this case, it's f of 1.75, and so that's going to give me 2 times 1.75 squared minus 7 times 1.75 times 11. And so that gives me 2 times, yeah, number in there, 2 times 1.75 squared minus 7 times 1.75 minus 11. Negative 17.125. So that's my vertex. 1.75, negative 17.125. Question or concern? Now, just out of curiosity here, is that a high point or a low point? Which way does this open? A is positive 2, so we didn't talk about that, but this one opens up, right? So is that a high point or a low point? It's a low point, yeah. Okay. All right. Question? I think I'll ask you that, but think it. Since it opens up. All right. Anything question-wise? That.